objective of an experiment to determine the velocity of the horizontally projected object, a metal ball fired from a spring gun. Theory of the experiment. Ballistic pendulum used to measure a bullet's momentum, which it is possible to calculate the velocity and the kinetic energy. In a perfect elastic collision, bullet is fired into stationary pendulum. Bullet is captured and the energy is observed. Stationary pendulum is moved with a new velocity after the collision. Not all the energy from bullet is transformed into kinetic energy. The momentum is conserved. By measuring height of the pendulum swarm, the potential energy of the pendulum when it stops can be measured. Total mechanical energy is conserved. Kinetic energy is fully converted into potential energy. An initial velocity of pendulum is calculated by law of conservation of momentum is used to compute the velocity of bullet. 1/2 bracket m plus capital M bracket v squared equal bracket m plus capital M bracket gh, where m is mass of bullet, capital M is mass of pendulum, h can be maximum height reached by the pendulum, and v velocity of bullet or velocity of the pendulum, and g is gravity of Earth. According to the law of conservation of momentum, velocity of the metal ball is given by v equal to bracket m plus capital M bracket over m square root 2gh. Apparatus of the experiment are: first, ballistic pendulum used to measure a bullet's momentum, and second, spring gun used to fire the bullet.
Now, let's take a look at the procedure of this experiment. First, the mass of metal ball and pendulum were measured. Second, the gun was fired and number of notches in which pendulum come to rest were recorded. Third, height of the center of the mass marker from the base was measured. Fourth, when we got average number of notches, the pendulum was raised to that notch. Repeat step 3 and the difference between the two heights was recorded. 5. Using the formula U equals to mass of the pendulum plus mass of the metal ball divided with mass of the metal ball times square root 2gh, the initial velocity of the ball was calculated. Next, we look at the data. We got mass of the metal ball, which is small m, is 20.1 plus minus 0.1 times 10 to the power of negative 3 kg. While mass of the pendulum, which is capital M, we got 116 plus minus 1 times 10 to the power of negative 3 kg. So this is the result of the experiment. We use 9 trials and we get the H and U. Now let's take a look on how we can calculate the U. So here is mean the initial velocity of the metal ball.
We can use this formula to find U. U equals to mass of the pendulum plus mass of the metal ball divided with mass of the metal ball times square root 2 GH. G is gravitational acceleration, which is 9.81 ms-2, and h is height. Now, let's say we take trial 1 as example. We can just substitute the value from the trial 1 into this formula and we get 5.8437 for the trial 1. Now, repeat the same step to find the U for the trial 2 until trial 9.
After we got the average U, we can calculate the uncertainty using this formula. Uncertainty, total sum mass of the pendulum and mass of the metal ball divided with total sum mass of pendulum and mass of the metal ball plus uncertainty of mass of the metal ball divided with mass of the metal ball plus uncertainty of the height divided with the height. All of this we divided with the average U that we calculate earlier. So, just substitute all the value into this formula and we got 0.0164 for the uncertainty.
From this experiment, what we can conclude is this experiment support the conservation of momentum and conservation of energy through the inelastic collision of the ball and the pendulum. We got to find the velocity of the metal ball, which is 5.7549 s-1, that achieve the objective of this experiment, which is to determine the velocity of a horizontally projected object fired from a spring gun. The object here is the metal ball, but we also got the uncertainty from this experiment, which is 0.0164. The biggest contribute of uncertainty is the possible error. First, energy loss in the swing due to the pivot. It affects the swing to the certain length to reach the notch. Second, air resistance during the release of the metal ball to swing. This will cause the decreasing of velocity of the metal ball.